Let's try another example now of using the extreme value theorem. So we want to find the absolute extrema of this function, but we have a domain issue. So our denominator here, our t minus 1, cannot equal 0, so t cannot be 1. So we know our domain is all real numbers except for 1. So now we can go and do our problem. So what I like to do with each of these is to honestly just plug this into our calculator with that interval and get an idea of what our problem looks like. So alpha y, number 1, and then we get x squared over x minus 1. And then click on our window, and we plug in -2 and 0.5. And then hit zoom 0. And so we can get an idea of what our extreme values will be. Okay, and then we draw a nice little picture of it. So it does that. And so looking at this, we're going to have one critical point between our -2 and our 0.5. So let's take our derivative and see what we get. So f prime of x will equal, and we have to use quotient rule. So we have t squared and t minus 1. So that will be 2t and 1. And then using quotient rule, we get 2t, t minus 1, minus, and then t squared, all over t minus 1 squared. Okay, and a little distributing. So we get 2t squared minus 2t minus t squared. And leave that bottom one alone. We already know that one of them is t equals 1. So f prime of x equals 2t squared minus, so it's t squared minus 2t over t minus 1 squared. So this is t, and t minus 2 over t minus 1 squared. So we get our critical numbers. So again, remember, top is equal to 0, bottom is equal to 0. And so we get our critical numbers at t equals 0 and t equals 2. Now we don't get to include the bottom one because t cannot equal 1. And so if I wrote that, which is fine to write, you then have to go back to your domain and cross it off. But it started as a denominator, so it's going to continue as a denominator, and it's not going to be included. So now what we have is 0, 2, and -2 to 0.5. So let's plug those in the table and see what we get. So we have our endpoints of -2 and 0.5, and of these that fit, it's only 0. So now we can check to make sure that is our critical number in our graph. So if I hit trace and 0, it says 0. It's not showing up because remember, it's outside that little window. So if I come down here, put my y max, I get 5. So I'll get some height out of it. Trace 0, and you can see there it is. That was our max. So that works perfectly. And now we're going to find our y values. So 0 is 0. And we have to do -2. And that's -4/3, or 1.33. And then trace 0.5, which we already know is going to be higher at -0.5. Okay, so we can see that we have a minimum value here. And remember, using the calculator, you can clearly see it, but just by numbers. -4/3 is the smallest, so that is our min. Our min. 0 is the highest, and that is our max, which makes the value we got at 0.5 neither. And so we can say we have an absolute max of 0 at t equals 0, and an absolute min of -4/3, or 1.33, at t equals -2. And then we verify it in the calculator. Right there. There's our max, and there's our min. So at -2, we have a min of -4/3, and at 0, we have a max of 0. And there you have it. Now, one thing I didn't mention is why were we able to do this? And we have to go back to our extreme value theorem. And so remember the extreme value theorem, we have to have a closed interval. And it needs to be continuous. And so it was discontinuous at 1, but 1 is over here. So on our closed interval, it is continuous. We would go from -2 to 0.5. So we do have a continuous closed interval.